This is test 5, metric and imperial unit conversions, version 1, and the solutions for it. So let's get right into it. Convert the following units, 1 point each, 450 nanometers to meters. So jumping to our formula sheet here, we can always use our table. We are going from nano to meters here. Meters of the base unit, that's the gray bar. Going from here, I see that I have a 1, and the 1 is here now. My decimal would be right after the 1 here. The decimal here needs to move 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right here. So my number needs to move 9 places to the right to go from nano to meters. So I know I need to move not the decimal point 9 places here. Do I move it to the left or the right though? Again, another trick looking back to our formula sheet. If we are going down the chart, we multiply. If we are going up the chart, we divide. Now we are given nano, we are going to meters, we are going up the chart, so we divide by a 1 with 9 zeros after it. So we're going to take 450 divided by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, otherwise known as a billion here. And that will leave us with an answer of 0.123456450 meters. That is our answer. So when I do a bunch of conversions like this, that is how I'm using the chart. That is how I'm moving around it. Same idea here from attoseconds to picoseconds. This time the difference is 6 decimal places. So this ends up being 0.25 picoseconds. So shown here. This time, I'm just going to erase this quick. Just all this. Again, we are going up. We are going from atto to pico, right? And we are moving 1, 2, 3, 4, 5, 6 decimal places for this here. So that is why I knew to move 6 decimal places. I also knew I was going up, so I knew I'd have to move them to the left. Or I'm going up, so I have to divide, which moves it to the left. Would be more accurate. Here, 2.3 miles to yards. We need our conversion to miles and yards. Here we have 1 mile equals 1,760 yards. So 2.3 times 1,700, that looks more like a 2. 760 yards gives us 48 yards. Oh my gosh. There we go. That looks way better. Great. 24 degrees Celsius to Fahrenheit. Checking the formula here. We are given Celsius. We want Fahrenheit. So this is 9 over 5 Celsius plus 32 is our formula here. So we're going to do 9 over 5 times 24 plus 32. And that gives us 75.2. Let me write this a bit neater. 75.2 degrees Fahrenheit. There we go. 1 metric ton to 1 standard ton. Now, if we look at our formula sheet on mass and weight here, we have 1 metric ton equals 2205 pounds, and 1 standard ton equals 2,000 pounds. We don't have direct metric ton to standard ton, so that's essentially what the question is asking you to do, is to create a different conversion here, 1 to 1, almost. So let's figure it out. We're going from, I believe I said metric to standard, so 2205. Yes, 1 metric ton to standard ton. So a metric ton, by the way, is also known as a ton, written like this. Standard ton is also known as just a ton, so I'm going to use this as a short form. We're going to have 1 ton times 2205 over 1 pounds, sorry, lb, over 1 ton. That is direct from the formula sheet. Times 1 regular standard imperial ton over 2,000 pounds. So what this ends up being equal to is just 2205 over 2,000, which gives us 1.1025 tons as our answer. So that was question 1, parts A through E. Question 2. Excuse me. I think during the actual test, I had missed the 1/2 fraction. I forgot to go and add that back in. So yes, I did. So looking back, our answer here in this video is going to be just ever so slightly different than the real answer that was on the test. It's the exact same method. If you can follow along with this in the video, you can do the one for the test, because this one here in the video is slightly more difficult. So, a metal bar has some pieces cut off of it for a project. The bar is longer than the total length needed. That is important. That means we don't have 1 less cut to make. If it was the perfect length, it is too long, so we do have to make all 5 cuts. We'll get there in just a second, though. There are 3 18.5-inch pieces, 2 450 millimeter pieces, and every cut wastes 5 millimeters. What is the length of material that will be removed from the original metal bar? Okay, great. So first I'm going to find the total length of everything, basically. So let's do this. We have the 18 and 1/2 inch pieces, so otherwise known as 18.5 inch pieces, and we have 3 of them, so I'm going to multiply this by 3. Great. And add to this the 2 times 450 millimeter pieces. Great. And then I have 5 pieces total here. 3 of the 18.5 inch, 2 of the 450 mil. So that's a total of 5 pieces total. So 3 plus 2 equals 5 pieces total. Great. And we waste, it was 5 millimeters for every cut. So I don't really know why I have all the brackets. I'm just going to erase them. I don't need them. So that is everything here. So we're going to have some length needed for each of the waste amounts for every cut, as well as the actual amount needed for all the bars that we need. So adding all of these together will give us our answer. But first we need to do some multiplication and figure out some unit swaps. So going to leave this in inches just for now. Oh, I should also mention we also are tasked with putting our final answer in meters here. So we will be doing this. So 55.5 inches to millimeters. Let's see if we have this. Perfect. Our first one under distance is 1 inch equals 25.4 millimeters. So 1 inch equals 25.4 millimeters. Great. That's what we're going to be using. So we are going to multiply this number by 55.5. So 25.4, great. This is 1409.7 plus, and if I, and sorry, this will be in millimeters. And now all of this is still the same. And now let's add everything together. And I have a total of 2334.7. And again, this is in millimeters. Converting this to meters, I divide by 1,000 because there are 1,000 millimeters in a meter. This is 2.3347. And that will be meters. Our exact answer in meters there. Great. Number 3, the tires on my car must be inflated to an internal pressure of 36 psi. Convert this to kilopascals, rounded to the nearest whole number. Okay. Let's see what that conversion is. Pressure. 1 psi equals that long decimal of kilopascals. So that is 6.894757. Okay. So we are going to multiply this by 6.894757 to give us 248.211252. Great. So now that we did our conversion, we know that this is in kilopascals, but we are not done. It says rounded to the nearest whole number. So this is just going to be 248 kPa. So that was questions 2 and 3. Question 4. A bullet travels at 1,130 miles per hour to reach its target. I believe this was a realistic speed, but I'm unsure of muzzle velocity speeds in imperial measures like this. So how fast did it travel in feet per second? So I'm going to start by putting 1130 miles over 1 hour. So I'm just writing out my starting number here. Converting 1 hour to seconds. Well, there are 3,600 seconds in an hour. So we'll multiply by this fraction here. And let's convert miles to feet. There are 5,280 feet in a mile. If you're not sure where I'm getting these conversions from, check the formula sheet. The time 1 hour to seconds, is not on there, but what hours to minutes is, and minutes to seconds is. So from there, you can put this together with just one extra step. Punching all this in a calculator, you get 1130 times 5280 divided by 3600. That'll give you 1657.3 repeated feet per second. That is our exact answer here. Great. Part B, does the bullet travel faster than the speed of sound? Now, I give you the speed of sound in meters per second. We have our answer in feet per second. So basically, let's just go ahead and take our 343 meters per second and convert that to feet per second. So let's go check our formula sheet here. We need meters to feet or feet to meters. Is that one on here? No, I guess we'll go to inches first then. Okay, well, 1 meter is 39.37 inches. Okay, so I'm going to take 39.37 inches over 1 meter here. Great, and then I know that there are 12 inches in a foot. So what I'm going to be punching in the calculator is 343 times 39.37 divided by 12. And give me something. So 343 times 39.37 equals that, divided by 12 equals 1125.32583. Doesn't really matter. Feet per second. So the speed of sound is 1125 feet per second, which is quite a bit smaller than our feet per second for our bullet here. So therefore, yes, it does travel faster than the speed of sound. Great. I don't know where that circle went. Oh, there it is. It's back. So that was question 4. Question 5. I hope at least somebody got my Star Trek reference here. I think one person did, maybe 2. A Federation spacecraft travels 425 cubits to reach a distant planet. In this problem, 1 cubit equals 3,200,000 kilometers, and 1 AU equals 149,600,000 kilometers. Part A here, how far does the spacecraft travel in astronomical units? Also, before I get too far into this question, full disclosure, I'm not a huge Star Trek fan, just never got into it, so apologies if a cubit actually has a defined value in the show. A quick Google search, trusting the Google AI, told me that it didn't have a defined value, so I made one up. Who knows if that's right? I don't know how long a cubit actually is, and I'm not even entirely sure that a cubit is a unit of measure in the show. So, sorry if I got stuff wrong. Anyway, we are asked to find 425 cubits in kilometers. Now, unfortunately, we don't have a conversion directly from cubits to we're looking for it in AU, astronomical units, but we don't have a conversion directly from cubits to astronomical units. However, we have this middleman step of converting to kilometers first. So, using the same method here with the fractions, we are going to get our 425 times 3.2 million which is going to get us 1360. So yeah, 1,360,000,000 kilometers, which is going to get us 9.09 repeating AU, astronomical units. Oh, I should, oh no. Okay, I'm gonna do this a slightly different way. Okay. I'm gonna take my 1360 and divide this by 149,600. There we go. And that will give me 9.09 repeating AU. There we go. Now I feel like that makes a bit more sense. Great. So that was part A done. Part B, the planet is actually 12 AU away from the spacecraft's starting point. So if we've only traveled a little bit over 9 AU and it takes 12 AU to get there, oh, well, we're not there yet. So that is probably going to come into play here. That question actually asks, how many qubits farther must the spacecraft travel to reach the planet? So yeah, this is exactly where this comes into play. So we're going to take 12 minus our answer. It's going to give us this here as our remaining number, our remaining answer. So that is how many AU we have left to go, but we need to know how many qubits farther this is, so we are going to convert this back by multiplying by 149,600,000 kilometers to get 435,200,000, so 4,352,000, or sorry, 435,200,000 kilometers. And we're going to divide this by our 3,200,000 number to get exactly 136 qubits as our exact answer here. And that was every question, I believe. Yes, it was. So if you have any questions, please feel free to email me or ask me in class.